The majority of aircraft spark ignition piston engines are fitted with dual ignition systems. That is, they have two electrically independent ignition systems. Generally, the engine is equipped with two spark plugs for each cylinder and two separate engine-driven magnetos. Each magneto supplies electrical power to one spark plug per cylinder. Dual ignition systems serve two purposes. Firstly, the risk of engine failure due to faulty ignition is reduced. And secondly, by igniting the mixture within the cylinder at 2 points, the combustion time is reduced, thus reducing the chance of detonation. Magnetos are self-contained, engine-driven electrical generators, which produce the high voltage required for the spark. Within the magneto, a rotary switch called a distributor directs the voltage to the plugs in the correct firing sequence. The magneto combines two basic principles, that of the permanent magnet generator and that of the step-up transformer. This diagram illustrates the first basic principle, that of the permanent magnet generator. The only modification to the standard machine is the addition of a contact breaker which collapses the magnetic field in the primary circuit more quickly than would normally happen in a generator of this type. The second basic principle, that of the step-up transformer, is utilized in the secondary circuit. The secondary windings form a step-up transformer which consists of thousands of turns of very thin wire. A very high voltage spike is induced into the secondary windings by the rapid collapse of the magnetic lines of force, which occurs when the contact breakers open. The faster the magnetic lines of force can be made to collapse in the primary circuit, the greater will be the voltage induced in the secondary windings. To ensure that the primary field collapses as fast as possible, and also to prevent the contact breaker points being eroded by the sparks which would occur across them when they opened, a capacitor is placed in parallel with the points. Once the high voltage pulses have been produced, they are passed to the spark plugs in the correct firing sequence. This is done by the distributor. The distributor rotor arm rotates at half the engine speed. To give control of the magneto, an ignition switch is fitted in its primary circuit. Notice that when the ignition switch is placed off, the contact breaker points are short-circuited. This makes the points now incapable of breaking the current flow in the primary circuit, so no rapid change of current flow or magnetic flux can occur. The secondary circuit is still cut by magnetic lines of force, but their waveform is generally sinusoidal in appearance, so there are no peaks which could generate sufficient voltage for a high-tension spark. For illustration purposes, it's supposed that the system shown keeps running in the ignition off period because the propeller is windmilling. If, on the other hand, the aircraft was stationary and the ignition switch was left off, the engine would of course stop.